We're going to take a look at parametric functions. Alright, so go ahead and make a tab. Alright, so what is a parametric function? A parametric function enables you to define x and y in terms of another variable, usually t. This is a listening check. Underline the title, parametric functions. Right, let's take a look at an example. If x is t squared and y is t to the 4th power, find dy dx. So I want to find the change in y with respect to x. So first you need to find the derivative of each of these functions. But notice the derivative is in terms of t. So this is dx dt, and that's 2t, and this is dy dt, and that's 4t cubed. Okay, but I need it in terms of dy dx. So what I'm going to do is use the derivatives to find what I'm looking for. It's a listening check. Color in the sentence that we're writing right now. So I'm looking for dy dx, which means I need dy on the top, and then I need dx on the bottom, and whatever two things cancel out in terms of t, because that's what my function is in terms of t. So dy dt, dt, dx. Alright, so you can see I have dy dt, but I don't have dt dx. So sometimes you may need to flip one of the derivatives so that it can work out to what you're looking for. So dy dt is okay. So that's 4t cubed, but dx dt, I'm going to have to flip it in order for it to become dt dx, so 1 over 2t. Then go ahead and simplify that. This is a listening check. Put a triangle around number 4. So 4 divided by 2 is 2, and then t cubed divided by t is t squared. Alright, now this is still in terms of t, but I really need to take the derivative with respect to x, so I need it in terms of x. So rewrite in terms of the variables of the question. So looking at the question, I know x is t squared. So I can replace t squared with x. So dy dx is 2x. A lot of these questions, there is no set way of doing it. It's just kind of, you gotta figure your way through it and just kind of work with what you have. Alright, so let's take a look at another example, which you'll see has nothing to do with what we did in the first place. You just have to practice these questions, no other way. So what curve is represented by x equals cosine of t and y equals sine of t in that interval? Alright, so you know from trig identities that sine squared of t plus cosine squared of t is equal to 1. So now we can substitute what we have in our question. So substitute x for cosine t and y for sine t. This is a listening check. Put a box around example 2. And if you square them, you're going to get x squared plus y squared equals 1. Now what is this? This is the equation of what? A circle, right? So this is the equation of a circle with the center, the origin, and the radius of 1. And so this is what I mean, like every question is different. You kind of just gotta work through it and do as many examples as you can. Let's take a look at another one. Find the equation of the line tangent to the curve at x equals, this is a listening check, color in example 3. 2 cosine t, I don't put the 2 there, but I will later. 2 cosine t and y equals 3 sine t at t equals pi over 4. Okay, now this one is a more popular one that you'll see. So x is equal to 2 cosine pi over 4 and y equals to 3 sine pi over 4, just substituting what t is. Alright, so using your finger, you know that cosine of pi over 4 is radical 2 over 2. So I have 2 times radical 2 over 2, which is gonna, the 2's are gonna cancel out and leave in radical 2. And then I have 3 times sine of that is also radical 2 over 2, which leaves 3 radical 2 over 2. So I've got an x coordinate, y coordinate, now I need a slope. Alright, to find slope, I can take the derivative of each of those, so dx with respect to t, and the derivative of cosine is negative sine, so that's going to be negative 2 sine t. And the derivative of y with respect to t is going to be, sine is cosine, so that's going to be 3 cosine t. Alright, but I need dy dx, but I need it with respect to x, so dy over something times something over dx has to be dy dx, so it's dy dt, and we're just going to set it up. So dy dx is equal to dy dt, which is 3 cosine t, times dt dx, but I've got it flipped, so I need to flip it. So it's going to be 1 over negative 2 sine t. Combine those together, I'm going to get negative 3 cosine t over 2 sine t. And that's my slope. So now I find it when t is equal to pi over 4 by substituting pi over 4 in each of those things. I'm going to get negative 3 times radical 2 over 2 and 2 times radical 2 over 2, which simplifies if 3 radical 2 over 2, and the 2's cancel there, just leaving radical 2. Then we're going to do sandwich or keep change flip. So you're going to get the same thing on the first and then flip the second, so it's going to be 1 over radical 2. The radical 2's cancel, leaving negative 3 over 2. So that's my slope. So my slope is that, and then my x and y coordinates are that. And then we're going to plug it into the equation of a line, which is y minus y1 equals mx minus x1. So just plug in the stuff in. So y minus, what's y1? 3 radical 3 over 2. M is equal to negative 3 over 2, and then x minus radical 2. Alright, we're going to get it in, distribute, and we're going to take that negative 3 radical 2 over 2 to the other side, so it makes it positive. And then we're just going to simplify. So negative 3 over 2. And because these are the same denominators, I can add them. So it's the same thing twice. So that's going to be 6 radical 2 over 2. This is a listening check. Color in the answer at the end of this problem. And I'm just going to simplify. 6 divided by 2 is 3. So 3 radical 2. And that's pretty much it. Okay, so one of these things you just have to practice. And that's all you got to do. So let's practice.